Hello everyone, this is Andre Herman and I will be showing you how we are developing an alternative keyboard for communication of patients with amyotrophic lateral sclerosis and the results we have found so far. We'll be talking about what exactly we are developing, why we are doing this, and how the development is being made, along with more details about the technology we are using and the applied methodology. As you can see, it's an alternative keyboard. Although this was already clear in the title of this presentation, now you can see how it looks like. So let's talk about its features and characteristics. First and most important, this keyboard was designed to be used by patients with amyotrophic lateral sclerosis, or ALS for short. In advanced stages of this disease, only some facial muscles are functional, such as the muscles that move the eyes and the eyelids. As a consequence, those patients ultimately become severely speech impaired and also movement impaired. They cannot interact with computers in usual ways, like moving the mouse and typing of the keyboard. So, to give patients ability to communicate, we have to find an alternative way of communication. That's the reason why we are doing this, and that's the reason you're seeing this red rectangle moving around the screen. We have developed a system that uses the computer's webcam to detect the user's eyes and also detect when the user is blinking. The blink tells the software that a selection was made, and the user wants to interact with that particular selected item. And that was how we did it. As this video was made to talk more about the keyboard and its features and characteristics, I invite you to read the full article if you are interested in the development details. At this point, it's important to keep in mind that every feature and characteristics was chosen in order to improve the user experience in typing. One way of measuring the quality of the user experience is by counting typing speed, measured in words or characters per minute. So, in this work, we will compare how our keyboard performs with different layouts and compare the results with some other keyboards found in literature. The keyboard has the following features. Letters sorted by most frequently used in the Portuguese language. As we are using a timer to move from a region to another, ordering the letters this way improves the typing speed. Key negation. Another way to improve typing speed is to not show letters that do not follow the one that was typed before. As you can see, the scanner jumps all negated letters. List of predicted and most used words. Words are predicted after each key press. In this way, the user can rapidly choose the desired word if it appears in the list. Line column method of scanning. As a cost of one additional blink, the user can select letters that are below the first selected one. As you can see, the scanner hovers each individual key in a linear way, one key after another. If the user wants a letter in the second row or below it, he has to blink first to select the column, and second to select the row in which the letter is located. If he wants a letter in the first row, he has to blink twice in the same letter. Additionally, we added a text-to-speech as a quality of life feature. By doing this, we are allowing the user to communicate with others by pressing a button. Now that you know how the keyboard works, let's put it to test with different layouts and compare the results. We tested 3 different layouts. The normal QWERTY, the one explained before that we are using on our solution, and another form of the same keyboard, but this time with more rows. We are testing this new layout, the one with more rows, to show the power of the line column scanning method. By definition, this method of scanning works better in a more square shape. a simple software was developed to test the different layouts and check the keyboard typing efficiency. It simulates the user typing. The simulations consisted in typing 97 sentences in the Portuguese language, taken from books of several subjects. The result is a typing speed average, measured in words and characters per minute. We can now confirm that the new layout, the more square one, performed better in this test, showing that line-column scanning method is more efficient in square layouts. Another interesting conclusion is the confirmation that an ordered letter layout is more efficient than the traditional QWERTY layout. It is important to note that the mechanism of letter negation was not simulated. This would increase the count of words per minute by a significant amount. Also, with constant use, the user would get better with the keyboard usage, resulting in an increasing average of words per minute count. Despite our keyboard uses a method of scanning each key to select a letter, it's showing to be quite efficient compared to some keyboards that uses devices to capture eyes movement to move a pointer on the screen. They are intrinsically faster because the waiting time between one selection and another is only the time taken to move your eyes to the desired direction. Of course, these are only synthetic results done by simulation. Other variables such as user comfort with a new layout different from the default QWERTY, and user fatigue due to long-time usage are not taken into account. Therefore, tests with real users are essential in order to either validate or refuse the results. Although the keyboard has been developed to be as comfortable to use as possible, some difficulties need to be overcome. The most obvious is the user initial difficulty in accepting a new keyboard layout, different from the QWERTY. In addition, keyboards using scanning methods should always look for alternatives to reduce the waiting time. The new proposed layout is an example of it. Finally, for a better user experience, the system should be capable of detecting other languages within the text, in both prediction and speech features.